Welcome back. In this video I'll show you how you can convert any 3D model into Minecraft blocks using BlockBlender. If you don't have BlockBlender yet, I've got great news for you. There's a free demo version you can download, and if you're one of the first lucky 50 people, you can use the code that's on screen right now to save 50% on the full version. And don't forget to subscribe to the channel. For everyone that is a complete beginner to Blender, it's definitely helpful to watch some basic tutorials on how to navigate in Blender beforehand. This will make it much easier for you to follow my explanations and fix your own mistakes. For extra support, there's an icon displayed in the bottom left corner of the video showing you which key combinations I'm pressing. The first step, of course, is to install the add-on. Here's how it works. Go to the top menu and click on Edit, and then on Preferences. A new window will pop up. There, search for Get Extensions. Make sure you go to the Extension tab this time and not the Add-on tab. This is important because since Blender version 4.0, a new extension format has been introduced. And BlockBlender 2.0 is one of these extensions. I'm using Blender version 4.3 here, and anything onward this version should work without any issues. Once you've opened the Get Extension tab, select Install from Disk at the top drop-down menu. Then locate the BlockBlender zip file and install it. Important, select the zip file directly and do not extract it beforehand. After the installation was successful, BlockBlender should appear directly in the list. Close the window and make sure you see the new BlockBlender tab on the right side. If you cannot see it, simply press the N key on your keyboard to open the side panel. At the beginning, you will see some error messages. That's because BlockBlender requires a specific Python library, the so-called NBT library. You can easily install it by clicking the gear icon in the BlockBlender tab. The add-on settings will open again, scroll down to the BlockBlender options and click Install Python modules. The library will be installed in the background, and afterwards the interface will refresh. You will now see the basic BlockBlender 2.0 user interface. It looks very different from the old version, more modern and organized. At the start, most options are going to be grayed out, and therefore this tutorial should give you a great overview over the add-on. I'll walk you through the features of BlockBlender using small examples along the way, so you can apply everything easily to your own models. So let's get started. To get you started, we'll first add an object to the scene. Let's take a cube for example. As soon as there's an active object in the scene, the BlockBlender settings will unlock. If you want to convert your own 3D model into Minecraft blocks, simply click the Turn Selected into Blocks button. If it is the first time for your current project, it might take a while because additional libraries are being imported in the background. Once your object has been converted, more settings will appear. You can now choose, for example, whether your object should use stairs or slabs, or whether the inside of your model should be filled or not. I'll explain all of these settings in more detail later on. Okay, a cube is fine, but what happens if you have downloaded a model from the internet and want to convert it? No problem. Let me quickly show you how it works. I'll delete the previous object using remove blocks and then remove it completely from the scene. Let's say you downloaded a skull as a 3D model. The model will then appear in the scene accordingly. To see the texture of the model, we will switch to the material preview mode at the top right corner of the viewport. I got the model from Sketchfab, and a link is in the description. At first, it's very nested and kind of unorganized, and therefore unusable. The first step is to select everything and pressing Alt-P to clear the parent relationships. Choose Keep Transforms so the parent-child relationships are removed and the transformations are preserved. Now you can delete all the unnecessary empties from the scene. You can identify them by their special icon in the outliner. You only want to keep the actual objects. After you deleted the empties, the relevant objects will remain. Now you can select all of them and merge them by pressing Ctrl and J or using the respective button on the BlockBlender menu. It's really important to take a look at the material. In this example, the skull has a material assigned. Open the shader editor and check what is being used. In this example, you can actually see it is an image texture that is used as an input. It's crucial to know that your model has to be either using a texture or an attribute, for example a vertex color. A simple base color is not enough and will not work. I explain it in more depth later on in this video. So the model must have at least one image texture. If that's the case, you can now click on Turn Selected into Blocks. Sometimes the model might disappear afterwards, and this usually happens because the scale and rotation haven't been applied. The first step in this case is to click Apply Scale and Rotation. If nothing changes, the model might simply be too small to be filled with blocks. And therefore, you might want to check the dimensions of your model. Here, for example, the skull is 8 by 7 by 4 meters. Scale your model by using the S key, for example to a height of let's say 30 meters. If the model still doesn't display correctly, it is often because the transformation values aren't set to 1. You can fix this by running the Apply Scale and Rotation again. After that, you should see the model properly displayed as Minecraft blocks. You can now scale it up even more to reveal more details. If you're still missing shapes or details, here's a simple tip. Change the voxelization method to better hole resistant. This will help the algorithm enclose holes in the model more effectively. Once you have converted your 3D model into Minecraft blocks, you now want to see the extra material of the Minecraft blocks. BlockBlender automatically reads the images or textures from your model, and therefore it searches for the closest matching block in the Minecraft block palette. You can delete unused textures or textures such as roughness, ambient occlusion or normal maps if they are not important. You can also assign additional textures manually if BlockBlender failed to detect multiple textures of your model. Currently, BlockBlender supports up to 10 different textures. Alright, here's another example to illustrate this. We've got a skull tower made up of many individual parts. This model is also from Sketchfab. Select all the parts and press Alt-P and choose Clear Parent, and then merge everything with Ctrl-J. You can delete any leftover empties and then scale the model as needed. Make sure you apply the scale and rotation and move it to the center of the scene if necessary. In this case, we'll scale the model to roughly 90 blocks height. Always make sure that no error messages appear. This is important so you can export the model later on without any issues. This model has a total of 4 materials and 4 different textures, which you can see in the Material tab. Material 1, 2, 3. BlockBlender will try to use all these textures correctly. But if it fails, you might want to check and correct the issues. Now, if you want to convert your model into blocks, click Turn Selected into Blocks again. But sometimes this doesn't work right away. So what can you do? One option is to change the voxelization method as mentioned earlier. This often solves the problem and improves how the model looks, but it cannot solve all the possible edge cases. However, if you want to use the volume-based method, which is more accurate, you need to make sure that there are no holes in the model. Otherwise, BlockBlender does not calculate the volume of the mesh. In our example, there's a large hole at the bottom. If you don't want to manually select all the edges, there's an easy method to fix it. Add a cube, scale it up and position it precisely over the problematic area. Then add a Boolean modifier to the main object and select the cube. After applying the modifier, you can delete the group and now you'll see the hole is cleanly closed. If you now reactivate the modifier, you'll see the volume-based method suddenly works. And this method often gives the most precise results. So you might want to keep this trick in mind. Alright, now let's have a look at the most important settings that BlockBlender offers. The exterior thickness option. This setting will expand the model outwards, making it thicker and bulkier. The interior thickness. This controls the thickness of the inner fill, for example whether a wall should be 1 or 2 blocks thick. The use slab or use stairs option. Here you can decide whether you want to have slabs or stairs to be used in your builds. Fill interior. This option fills the entire interior of the model with blocks. alpha channel. If your texture has transparent areas, you can set those areas to be displayed as empty blocks. The model height display. This will tell you exactly how tall your model will be in Minecraft. The layer view. With this option you can preview individual layers of your models, for example layer 1, layer 2 and so on. One especially important point is the UVMap section. BlockBlender uses the UVMap to reference the texture data of your object, and that's why this value should always be correct. If your converted model does not represent the correct texture at all, you can check the UVMap and the object data properties. The name of the UVMap is usually detected automatically. If not, you can synchronize it using the Synchronize button. If you rename the UVMap, make sure to synchronize it so the model texture is displayed correctly again. You also notice that the textures are automatically assigned. That's very convenient, right? However, you can also manually select them if you need. There's also an advanced settings section. It's best not to touch those settings at all. The most important thing is that the model scale and block size must always be set to 1. Otherwise, the export to Minecraft will not be completed and will fail. Another interesting button is the Use Color attribute, which we'll cover now. I'll quickly hide the current model and add a new object, for example a simple cube, and I'll scale it up a bit. If you want to convert this model into blocks now, without using any texture, and instead you want to directly paint it yourself, you can do that using color attributes. Therefore, we will switch to vertex paint mode. There you can color specific areas of your model. Make sure you're in solid viewport shading mode so you can actually see the vertex colors. Now, for example, we can paint the top area blue and the bottom half, let's make it red. If you convert the model now, the model might appear completely black. And this happens because there's a new attribute in the object data properties, usually called attribute or color attribute. And it needs to be synchronized as well. Also make sure you switch to material preview mode to see the actual block textures. So that means we'll go back from solid shading to the material preview mode. After that, enable the Use Color attribute in the BlockBlender settings, and now you should see that everything is using the colors you just painted. You can go back into painting mode and paint, for example, a bit of yellow onto the sides, and you'll now see that the color is correctly applied to the blocks. A great method to color code your models. If there are certain blocks in your model that you don't like, for example, I'm not a fan of those pink wool blocks, you can remove specific blocks in the block category section. You can disable things like color blocks, ores, or leaves. This way, blocks like wool or white concrete are removed from the selection. You also have the option to create your own custom block palette. To do this, open the block palette menu and select specific blocks, for example, dirt, coarse dirt, or birch. You can also search for specific blocks if you open up the little drop-down menu on the bottom. Activate the palette and BlockBlender will use only these blocks. You could also add something like acacia wood and see how it gets used in the model. Similarly, you can decide whether slabs or only full blocks should be used. If you don't like those sharp edges that are now visible due to a limited block palette, you can use the noise variation feature. Increasing the intensity will loosen up the pattern, introducing some noise, making the transition look more softened and more natural. You can also vary the colors and create larger patterns. This is especially useful for breaking up harsh transitions and generating broad and natural looking patterns. This feature was just added before editing this video, and it was actually submitted from one of you. So if you have a feature in mind that you want to see in BlockBlender, make sure to join our Discord server and submit your idea in the suggestion channel. Block integrity feature acts like a random block remover, perfect for making things like bushes or custom trees. You can specifically remove outer layers, giving the model an uneven structure. This is especially great for trees, and it creates a more organic appearance. Once you're happy with your model, you can export it as a schematic file. Make sure your model is active, that means it is highlighted with a yellow outline, and then simply click on the big Export Model button. Then choose a safe location where you can easily find the file again, and I would personally recommend using the direct schematic folder that Minecraft uses. Then click Export Model and wait a second. The export shouldn't take too long. During my tests with 2.5 million blocks, it took about 10 seconds to compute. The time it takes depends heavily on your own model. After the export is finished, you can directly switch to Minecraft. Personally, I use the Lunar client with Axiom as my import and model placement tool. It allows you to import your schematic files directly in-game, but you can also use mods like Litematica or WorldEdit. Start Minecraft and create a new world, for example, create a super flat world. Make sure you are playing the correct version. In my case, it's version 1.21.4. With Axiom, you can now import the schematic. Open the Import Schematic menu and select your saved file. After placing it using Ctrl and V, you'll instantly see your model in-game, exactly as you created it in Blender. If you later decide to add stairs or slabs, simply go back to Blender. There, enable the Use Stair and Slab option and export the model again. If you want to convert an image file, like a logo, into Pixelart, you will need to enable the Use Image Plane option when converting it into blocks. Without the setting, the image will disappear during the conversion process. Also, you need to make sure that the visualization method is set to Better Hole Resistant, as it is exclusive to this one method. Next, select your image as the texture and scale it accordingly. To remove any transparency in your image, simply toggle the Delete Alpha button in the setting menu. This will cleanly display your image as pixel art, and transparent areas will no longer be shown as glass blocks. You can then export the model as you did with any other model and import it into Minecraft as usual. For example, save it as pixel art, and once in Minecraft, import the file, and you'll instantly see your pixel art exactly matching the original image. Here, of course, you can also adjust the block selection and filtering. You can exclude specific blocks or define your own selections, perfect for creative adjustments and cool effects. If you have any questions, always feel free to ask them on the Discord server, the link is in the video description. What happens if your model has no texture at all? This can actually be a bit tricky. Let's say we got a Suzanne model in the scene with a simple material, like a checker texture for example. However, this checker texture isn't an actual image you can select directly, because it's a so-called procedural texture, and in order to convert it into blocks, you need to create a texture from this material and save it as an image. In other words, you have to bake the texture. If you try to convert it directly, it won't work. The model will turn black or appear broken. And this is where the awesome BakeLab add-on by Specular comes in. You can download it from GitHub using the Get BakeLab button in the BlockBlender settings. Then install it in Blender under the Add-ons tab, as it is a classic add-on and not upgraded to the new extension format yet. Once BakeLab is installed, you will see the Bake Texture button in the BlockBlender tab. This button is just a helpful shortcut and not part of BlockBlender itself. If you have issues with texture baking, check the BakeLab documentation. There are also great tutorials on how you can bake textures, so you might want to check those out too. Before you click the button to bake the texture, make sure you remove the BlockBlender modifier from the object you want to bake, as BakeLab will otherwise apply this modifier and create a real geometry from it. Make sure your model is unwrapped as well. This means it should have a UVMap to bake the texture onto it. To check if your model has a UVMap, go over to the UV editing space and tap into Edit mode. Press A to select all faces and look at the UV editor area. If you've seen a clean mapping of your mesh, that's great. If not, you can press U and choose Smart UV Project to create a simple UV map. There are plenty of great UV mapping tutorials out there as well, so if you want to learn more, you might want to check them out. I will link some of them in the video description below. If everything seems fine, you can click the bake button and wait a second. The time it takes to bake the texture heavily depends on your model, so be a bit patient. On the bottom there's a bake indicator to give you an idea if it is working. When the baking process is finished, you can use the create material to automatically assign a new material. Now your checker texture is a real image and you can easily convert it into Minecraft blocks. Keep in mind that baking may cause artifacts. You might need to experiment or adjust the UV map. To do this, go back into the UV editing mode and scale the UV islands if necessary to shrink or enlarge the problematic areas. Watch for black spots and adjust the points accordingly. If needed, you can fix smaller mistakes later directly in Minecraft as well. Another helpful toolset is the gradient tools, which you can import directly into your scene using the respective button. There are different types available: a circular gradient, a linear gradient, and a gradient with 4 different colored corners. You can choose the colors individually in the modifier settings, making it super easy to create beautiful color gradients. These tools also work based on attributes we discussed earlier. You can adjust the size of the gradients and add variations to make the model more interesting. This way, you can easily create seamless gradients that can also be transferred into Minecraft. And there you have it. You should now be ready to create your own custom builds with BlockBlender. If you got any questions, feel free to join our Discord server and use the code displayed on screen to be one of the first 50 people to get 50% off BlockBlender 2.0. I've got a lot planned for the future, which we'll talk about in the next video.